Thanks for joining. I'm glad you came in to listen about Java language extensions in SQL Server 2019. Before we go later, SQL Server SQL Day is supported by our sponsors, so big thanks again to them that we can meet today. Couple words about me. I'm Natalia Warszewska. I'm working at Atos as a senior application developer, where my time is split into two areas. I'm doing some ETL development, usually using Informatica tools and Amazon Cloud Web Services. And the second area of my job is real-time streaming intelligence, where I'm doing some streaming development in Groovy and Java. 1 year ago, I also joined the data community, and to be honest, they inspired me to prepare that presentation and be here on the SQL Day for the first time. In my personal life, I have 2 rabbits and 1 debugging duck to make my developers more efficient. And the plan for the day is basically to start with a story of SQL Server. Then we will go to a bit shorter story about Java, and I will refresh your knowledge in area which is SQL Server in Java. And we will end that part with a very short demo before we go to the main topic, which is Java in SQL Server 2019. The demo right after that will be quite long. So after that demo, we will go to the short summary, and I assume there will be still some time for a short Q&A. So in the very beginning of my development life, I knew about SQL Server, well, how to say, not much. I knew that it was a relational database management system, that it's a product of Microsoft, and that's basically the data platform where I can type SQL statements and do some analytics. To be honest, after that time, I have to admit, SQL Server is a way more than that. So over 30 years ago, version 1.0 was released. It's a very beginning of that story. In 1998, the version 7.0 introduced tools like Query Analyzer, OLAP, and data transformation services. Then in SQL Server 2005, it provided the SQL Server Management Studio as we know it right now. We are using it till the current days. So to be honest, in that area of time, many things, but rather to improve the on-premise scope and improve the work of developers and analytics. So what was the next step? The next step was definitely cloud. So one of the main features of SQL Server 2014 was the integration to Azure. Then, in 2016, Polybase support was introduced. So, as you know, with Polybase, you can query NoSQL data. Another interesting feature in that version was JSON support. So, it's kind of features to handle JSON's data. Since 2017, SQL Server can be installed on Linux and Docker, which is quite a huge thing. It's not only Windows. So this version, except for Docker and Linux support, it includes Python support. So also another language extension. 2019 presents data virtualization, big data clusters, and the most interesting for me, Java language extension. To be honest, I don't remember what was my first thought. No way, or just finally, after 22 years, we returned the favor. So I started digging deeper. And to be honest, I am expecting something more, like big banner on the main page of SQL Server about there is support for Java. No, there wasn't any big Java banner. After a couple minutes of clicking, I found it under developer experience. And after graph and Unicode support, I finally found the area where the Java support is described. Not much, but before we will go deeper, I would like to tell you a story about Java. So Java has a lot of cool features, but probably you've heard about Java, two most popular, that it's an object-oriented language and it's platform independent. These are, I think, the most popular. But the story about Java began in 1995. So 1 year later, from the beginning of the beta version of Java, 1996, in this year, the first official release of Oak was released. Yes, I told Oak because it wasn't Java from the beginning. The first name, picked by James Gosling, who is the father of Java, was Greentalk. Then, for official release, the name was changed to Oak. But why Oak? Oak is a symbol of strength, and also it's a picked national tree for countries like USA, Germany, Romania, and France. So that was quite good. Nevertheless, Oak was already the trademark for Oak Technologies. That's why they wanted to find something else. The propositions were like Dynamic, Silk, Jolt, DNA, but finally it became Java. There is one more guy to introduce. Probably you saw that graphic. This is Duke. Duke is a mascot of Java since the very beginning, and a living life-size Duke is a popular element of every Java 1 developers conference. So each year, Oracle releases a new Duke personality to show in the conferences. In 1997, next release named JDK 1.1 introduced JDBC. JDBC is a Java database connectivity. So since that moment, Java started communicating with databases. Yes. Then, after a couple of years, in 2010, Sun acquisition by Oracle happened. So since that moment, since January 2010, Java became Oracle. And now, in 2020, we have, since September this year, we have Java 15. Over those 24 years, a lot of things were improved. I won't tell you the story about each version and what changed, etc. There is a topic for totally different presentation. But so the name of language changed. The company changed. The third thing, which is different over those years, is definitely the naming convention. So it started from JDK. Then it was J2SE, so Java 2 Standard Edition. Numbering also changed, 1 point something to 5.0, only for one version. And then finally in 2006, naming convention of Java became stable, as till now. Nevertheless, if you have troubles to pick the right version of Java for you, for your development, in one of popular IDEs, IntelliJ IDEA, in the section named project level language, there is almost a full list of versions for Java. And next to every version, there is the most important feature related to that version. So it's quite easy to know where lambdas were introduced, since when we have modules, and since when, well, we have a text blocks, for example. Before we go to the main topic of this session, I would like to refresh your knowledge regarding SQL Server in Java. To make it happen and to let Java communicate with SQL Server, we need a couple of requirements. So first, which is kind of nice to have, is a Java IDE. You can, of course, you can open the notebook and type your code and compile it without using IDE, but IDE is quite a good support for developers in general. But the required thing is JDK, Java Development Kit, which is taking your classes, taking your Java code, and it's able to compile it and prepare the code, the binaries, which can be run on different environments. So the next thing is connection URL. Your Java code needs to know where is your database. So starting from the name of JDBC and the suggestion what driver should be used, there is IP, there is port number and information what kind of database you want to connect. Of course, you need also credentials to access your DB content and information about SQL Server driver if it's a SQL Server database, but definitely every database has its own driver to communicate. Inside the code, there are 3 more elements which are crucial to make it work. There is a connection, statement, and element which is named result set. You need to prepare your select statement or any element which you want to send to SQL Server. You have to pack it. And then after response of SQL Server, you need to take that result set and be able to process the results. In SQL Server, there's not much to do. You need SQL Server instance. And also when you try to communicate, well, when I started, I had to additionally open the TCP connection and the port 1433 when I've prepared the environment on my own. It's okay to show it on the slide, but I think the demo will be the easiest way to present how does it work. So let's go to Java code. And from Java perspective, I've decided to generate a very simple Spring Boot application using Spring Initializer, and I've created. For that demo, I need only main function. So in that method should be as simple as possible to show you how simple is that to communicate with SQL Server. So as I mentioned on the slide, you need to give your code information about where is your database, what is the name, and a bit not recommended to provide hard-coded password and username, but it should be definitely hashed or hidden in somewhere else, not in your main method, but it's not so important here. So you have credentials, you have your URL connection, and there's a good moment to start the connection. So there's a try catch, very similar to one which is available in SQL language. So there is connection, which is created based on URL, username, and password. And if it works, we will go and receive information that it was connected. In case of troubles, I will receive information about that communication failed. Right after establishing the connection, there's a moment for preparing statement. So I can do it in many ways. So the first example which I picked is preparing the exact statement, which can be also developed in SQL Server. After preparing that statement, I'm using the connection, create the statement instance, and using that statement instance, I'm executing the query prepared a bit earlier. In that moment, the query is being sent to SQL Server. SQL Server is doing its job and returning the result to Java code. And after returning the result set, I'm able to open it and process it and show in my terminal what was the result. So before that, I will execute the statement on SQL Server to be 100% sure that the result is correct. So I will execute that. The result is 41. So we have 41 category products in AdventureWorks database. And let's go with Java. I will just run the main statement. And Spring Boot worked. Yes, connection to SQL Server was correct. I reached the AdventureWorks database, and the answer was 41. Quite good. The other example would be to show you that you don't have to define the full statement in Java code. I can have also the procedure, which is where the code is partially prepared on the SQL Server side. So it's not so good when the statement is very long to prepare and combine it on the Java side. That's why I decided to pick one of procedures and execute it and allow part of the code be prepared on the SQL Server side. So let's check it if it really works. So yes, the procedure received the parameter with value 3. It returned information that it's backordered. Let's try if Java will do the same. So yes, starting again. Yes, again, the connection was successful, and the returned answer is the same as done in SQL Server. So just to be sure, comparing that it's backordered. Okay, so that's it. It's pretty simple. So let's try if. So SQL Server is very simple in Java. Let's check if it's is so simple when we use Java in SQL Server. So let me go back to my slides. Okay, so let's start with some requirements on the Java side and on SQL Server side. So on SQL Server, you definitely also need the SQL Server 2019 instance because there is Java extension. It's good to have Management Studio because if you want to prepare a statement, it's a big support. And also SQL Server needs to know where the Java runtime environment exists. To execute the code and understand the Java code, we need the JRE. On the Java side, it's good to have IDE, but you don't need it. You can use your notepad and prepare very simple code without any special IDE, especially when you need to prepare very only single class with some calculations. And there is necessary JDK because you want to compile that Java code to classes and then prepare a jar. About additional configurations, there is JRE home, which is good to be defined on SQL Server side. And when you are preparing your development environment for Java, it's nice to have a Java home and path updated. On SQL Server, then we have to define external language, which is Java, and because we are providing some code, we need to define external libraries to let SQL Server code use them and know where the code is located. And of course, procedure and queries, which will support the execution on SQL Server side. On the Java side, you need to prepare the code. But during the preparation, this is necessary to take one of libraries provided by SQL Server and use it in your code. So you're kind of extending the code provided by library and adding your own plugins and your own calculations, which will be dedicated to the example. And after having Java code, you're preparing bytecode and then jar files. Again, the best way to show it is demo. So I think the most complicated part for me was to install SQL Server. And there are two elements which are quite important when you are doing the installation. So very quickly, we'll go through those steps. I have installed the SQL Server on my local machine, but I want to show you where are the steps which are crucial to make the installation happen and to make it correct. So even you have already installed SQL Server or you are installing completely different element, you are just picking the new installation. It will go quite fast, so you will not be bored. The process is very similar for other languages like R and Python. So it's good to remember that. So of course, I'm selecting the SQL Server. I'm selecting which edition I want to pick. Developer is good enough for me, reading and accepting the license. And the first important point, when I'm picking the element which should be installed, I need to pick Java, which is language and extensions. For now, I don't need R and Python, but Java is crucial for the demo. So after that, I would expect to define something more than only defining that Java is my additional element. I mentioned about JRE, and SQL Server contains in the standard installation version of OpenJRE 11. To be honest, when I read some tutorials on SQL Server site, they are recommending the version of Java 8, which can be selected if you have it already installed. You can also use Java 15. If it shouldn't be a big problem. But let's stay with JRE 11. And I have also installed JDK 11, which will be used for compile my Java code. So let's keep the installation for now, because it's already done. And let's go to Management Studio. So first of all, we need to use a database. So I decided to use AdventureWorks. And first element, which is quite important, is to define an external Java language. So during the installation, we picked that the external language should be added, but we have to create it from a code. So the definition contains a content which is zip provided by SQL Server. It's attached into files of your installation. And inside that zip file, we have two elements. First is a jar named MS SQL Java Lang extension, which is crucial for also for developments on Java side. And there is a DLL file, which is required to create external language definition. I also decided to provide here environment variable, which is JRE home, to be 100% sure that my SQL instance knows what kind of JRE version we are using. Okay, it's completed. So let's go. And the next element after creating a language, it's good to create a library. So the SQL Server will know where is my Java code. First, the most important is Java SDK. So because our custom code is extending the a library provided by SQL Server, the SQL Server needs to have already added the link to that library. That's why it's also provided in the SQL Server. That's why without doing anything, I can just add that library using the path located in my installation. But for now, I want to add some custom code. But there is no custom code. I need a jar which will have my class inside it. So what can I do? If I have, it's also not the simplest step, and sometimes preparing that jar is not so easy because doing it in Eclipse will work a slightly different way in IntelliJ, and using a command line will also work differently. To be honest, not always SQL Server will see your jar. That's why don't worry if it will not work. With IDE support, just use a simple compile command and simple jar build command. So let's go to the SQL Server demo. Yeah, my first demo is starting with a simple Java. The simple Java is containing some code with two hard-coded tables. I want to allow my SQL Server procedure to show me two columns, where in the first column there will be information like conference, date type, session, and more extended description will be added into the second column. Okay, so I'm deciding to prepare two tables. I'm hard coding the values, and I will add it to primitive dataset to return it to my procedure in SQL Server. What is important, my class in Java is extending the class provided in SQL Server library. It's quite crucial. That's why we added the external library first, which contain those elements, and then I'm ready to prepare my code, and I'm sure that it should work on SQL Server side. But before that, I need to create a class, and I need to build a jar. So starting from this moment, yeah, let's here. First command, because I have already the Java code, I need to use the Java compilation command. So compilation command, and I am providing the information that my compilation needs to know that there is additional library which needs to be considered during the compiling code inside the simple Java file. Okay. And the result of that step is simple class. This is compiled element, so JDK 11, so Java version 11, it compiled my Java code into binaries here. but I want to add this in a package because I need to have a proper structure of my file. Inside the Java code, I mentioned that my class will be located in a package name in particular way. That's why I need a folder, and I need to take that folder, take class which is added inside that folder, and generate the jar. So jar will be named simple jar, and I'm defining that package will take all classes from package folder. Yeah, simple, very simple. And simple jar is now visible. That's why I can go back to my code and create external library using my prepared jar. So to be 100% sure that I have properly defined Java language and additional libraries, I'm executing two statements. Yes, I can see that there are languages like R and Python, and I can see my Java extension right now, and two libraries which are created from provided jars. Quite simple. Okay, so now there's a moment to prepare a procedure which will know that, which will have to execute the external script with Java language and know that the code is located in package in the class named simple. So we are providing the package, the full package path, and then the name of a class which is located in those. So yes, created. So let's execute it. Okay, so it worked. And you can see, as I expected, I wanted to I prepared in the Java code primitive data set, which is returned to SQL statement, and it contains two columns with some texts, which will be shown as a result of SQL statement. Okay, it's working. So SQL Server is ready to is able to communicate. Let's clear a bit before we go to another example. The next example will be slightly longer because I will use a code which is using a regular expression. So the purpose of that example is to take results from SQL statement executed in AdventureWorks table, send it to Java, and let Java do the job, and based on regular expression, take only those elements which are appropriate for the particular expression which I'm interested of. Okay, so again, the language is defined, environment variable added, and I have two elements to add, like external library, the main library again, and I have prepared before a different jar with SQL regular expression code. There's also one single class which takes the primitive data set, which is quite big as a result of statement. So, and it will do the job on the Java side, and it will return the result and only show it on SQL Server side. So let's add it. Again, one more check if those codes are visible. So Java extension it is, and Java SDK plus SQL regex are there. So I'm ready to build a procedure which will use my code. This time the procedure will have to use two input parameters, and Again, it will return two parameters. The first one is just the number of row, and the second one is will be the name of product, which is good enough based on regular expression procedure. Okay, it was created. So let's go here. Before I run that procedure, I will show you how the table looks like. So the table contains a lot of columns, but from my perspective, the important is the product name. And there are a lot of frame, logo, helmets, bikes, and my idea is to find all information about product related to bikes in product table. So I will do the select statement with product IDs and names and just provide it to Java code, and Java code will do the job and return me. It should return me only those rows which are which are having bike written in capital letters or small letters. It doesn't matter. So let's execute it and check if it worked. Yes, it is. So I have a product IDs and I have the names, the text which contain the bike information. So it worked. It was not so fast, but execution plan looks like this. So there is an index scan, 295 rows, and then external script, which resulted with 5 rows as a result set from Java. Okay, so let's compare. It looks like a simple statement which can be also done on SQL Server side. So let's do that and check how the execution plan differs from the one presented for external script. So because I know that every of those 5 rows contain the bike written in capital letters, let's just do not complicate it, and I will use the most simple like statement to check the products. And yes, the list of return elements is exactly the same, so the product IDs and the names, but the execution plan will be slightly different because there is no additional external step. So there is only index scan and 5 rows returned by the calculation. So for very small tables, it doesn't matter. So if you have a very simple calculation, it can be definitely delegated to Java code. It will not affect your performance, but I'm not 100% sure. Well, I'm pretty sure it will affect your performance if you decide to take a couple million of columns, pack it, send it to Java, and do everything in memory and send the big set to Java and back. So SQL Server knows that it's based on execution plans. SQL Server knows the difference, and the performance is definitely different if the set is bigger. But there are some situations where Java can really do the job and it will not affect the performance, and even it will extend possibilities provided by SQL Server. So let's go back for a while to slides. And do a short summary. So, to be honest, you can do everything in Java. You can prepare queries. You can even replace SQL Server by another data structures and totally resign from using databases. And the same situation is on SQL Server side. You don't need Java. It's something additional when what can be used as a cool feature and which can be kind of extension. So that's really good that we have opportunity to see since 20 years, we are able to build the code, communicate with SQL Server from a Java code, and present the results with delegating some calculations to SQL Server. And now I'm a very big fan of that feature, which is allowing to return the favor and execute part of processing in SQL Server and delegate some elements to Java. Even the SQL Server probably could do it in similar way. So there are three general advantages for the summary why the feature is good. First one is that it's just another nice feature, and it shows that SQL Server didn't stop, and it tries to be open to next area. The second thing is possibility to delegate processing. If you have a big SQL Server team, so there are a lot of SQL developers, that's cool. You can do everything on SQL Server side. But if you have if your team is combined with SQL developers and Java developers, you can split the tasks, and some of elements which are not directly affecting the performance can be developed by the other team. So you can easily achieve the deadlines having not only SQL developers. And the third one, which is I think the most important element, SQL Server is supporting a lot of elements right now and a lot of different data sources, but not all of them. And Java, I think, is quite more open. It's more open to the communication with different elements more than SQL Server. So you can take the Java elements to communicate with data sources which are not yet supported by SQL Server itself. Good feature again. So that's it from my side. If there are any questions, I think it's a good moment for that. Okay, so no questions? If no, so thanks a lot.
Pojawiło się pytanie. Can we do the same with C# and .NET?
With C# and .NET, that would be there is no definitely there is no element on the list with extended languages. So I'm not sure if SQL Server is planning to do so, but right now it's not explicitly defined on the list. So maybe in a different way, yes, but definitely not in the same way as Python, R, and currently Java. I haven't tested that. Is there any other question? If not, thank you for being here and enjoy the rest of the conference.